Long-distance migrations are perhaps the greatest wildlife spectacles on Earth. Every year, billions of animals from butterflies to blue whales fly, swim, walk and run across the globe. Birds migrate, Serengeti wildebeest migrate, salmon migrate. But why, lost in the Pacific, would a 600-pound Galapagos tortoise haul itself up and down a volcano every year? In the early 1800s, a young Charles Darwin, on a global migration of his own, sat on a rock on the Galapagos Islands and wondered why giant tortoise trails went up and down the volcanic islands instead of around them. The locals told the young scientist that tortoises migrated over the island. Fascinated by vague reports of long-distance movements by Galapagos tortoises, we asked, do tortoises truly migrate? Why? How? Who? When and where? Amazingly, these questions had not been answered for one of the most iconic animals on the planet. In 2009, we fitted GPS tracking tags to 10 tortoises on Santa Cruz Island, hoping to track their movements every hour over 2 years. The first year of data showed classic long-distance migration of tortoises between breeding grounds in the lowlands and feeding grounds in the highlands of the island.
So these highland areas are really a dry season refuge for the giant tortoises. And the way in which the migration works is that when the lowlands are dry and there's very little vegetation, the tortoises migrate up to the highlands for these fallback resources, where the highlands are always wet, there's always wet soils, there's always productive plant growth. In the lowlands, it isn't the case. But when the rainy season kicks in January and February, the lowland, dry, sort of desert conditions almost really very quickly bloom, and you get this very clear greening up of the lowlands. So pretty much the entire population migrates down to the lowlands, feeds up for 2 or 3 months on that high quality food. And then when the rain stops, plants begin to dry out, wither and die. And there's less and less food for the tortoises down there. And that's when the upland migration begins again to this secure, sure resource.
Tortoises take 2 to 3 weeks to complete a one-way trip that may cover 10 kilometers. Often, migrations occur on open, well-used tortoise trails, but sometimes the tortoises doggedly clamber over lava boulders and push through near impenetrable vegetation, or even both at the same time. The seasonal change in food distribution that drives the migration is caused by interactions between shifting weather patterns and the topography of the island. Yet every island is different, and many islands have giant tortoises. We wondered whether tortoises on different islands had evolved different movement strategies. So we tagged 10 tortoises from each of 4 different species on 3 islands: Santa Cruz, Alcedo Volcano on Isabela, and Hispaniola. Lo and behold, we found big differences in tortoise movements. On Santa Cruz, most, but not all adult tortoises migrate. On Alcedo, all tagged adults migrated, but mostly around the caldera of the volcano.
We're at the sulfur springs, which is about a 3-hour walk from the epicenter of the dry season end of the migration. And this is about a 2-week walk into the migration for most tortoises. These sulfur springs are kind of a pretty important stop-off point for the tortoises. It seems that most of them like to come through here for a few days, and probably just for ease of thermoregulation. They can warm up really quickly on these hot rocks. Tortoises hang out here for 2 or 3 days and then continue their migration around to the far end of the caldera. For me, this is like the quintessential image that I had of Galapagos growing up as a kid. You'd see it in the books, you'd see it on the Attenborough films, and to be standing here studying giant tortoises in Jurassic World is a pretty special thing.
Hispaniola tortoises didn't migrate. Rather, they had small home ranges, usually centered around a cactus grove. Darwin would not have been surprised. Just as the unique environment of each island leads to evolutionary change in the form of animals and plants, why shouldn't the behavior of animals change as well? As usual in science, our work has generated more questions than it answered. How does movement evolve? When might migrants be fitter than non-migrants? Is migration behavior inherited? What are the consequences for the ecosystems of Galapagos? And perhaps most importantly, how can migration be conserved in a rapidly changing world? The lifespan of giant tortoises puts conservation strategies into perspective. Without doubt, there are tortoises on Galapagos today that were alive and well when Darwin was writing his masterwork on the origin of species. Some of our GPS-tagged tortoises were already migrating on Alcedo when Abraham Lincoln was president. Hatchlings born today could be alive in 2200 AD. We initiated the Lifetime Tracks project to document the lives of tortoises. Fresh from the nest, we fit radio receivers onto hatchlings and follow them over time, recording how they live, how they mature, and how they die. We are discovering the lost years in the lifespan of some of the oldest living animals on the planet. We've joined forces with the Icarus initiative that uses communications technology from the International Space Station, including tiny and revolutionary 1 gram GPS tags that talk directly with the station and a smartphone, to document the fortunes of these tiny infants as they march toward the 23rd century. With luck and a caring society, some will get there.